For coming. Welcome to another meetup of Brussels Developer User Group. My name is Luis Valencia. I'm Solutions Architect at PwC Belgium, Office Development MVP for the last 4 years, with a few years of experience also as a developer. Recently got the Azure Certified Solutions Architect and the founder of this group. The group is already been 6 months, and this is the third meetup. Can you please confirm you are listening to me? I'm sharing the screen. Everything good? Great. You can see my Twitter handle there and my blog, where I will share the presentation and the recording in a few days. For the social networks, you can see them on the screen: Brussels Dev UG, Brussels Dev UG for Facebook, the LinkedIn group, and the Meetup group. Feel free to send me a message if you want to share some knowledge in another session. Everything related to development, it's welcome. So we came here today to talk about machine learning, but let's talk first about the fundamentals. If you are going to explain machine learning to somebody new, or if you want to write a blog post, an article about machine learning, the first things that you're going to see is this self-driving cars, medics curing cancer, facial recognition, and you can download a template like this where you put this image and you fill the blanks with blah 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 blah, and you get a really nice machine learning definition, and you got your audience. But it's not that easy, right? That's the hype definition, but we also have the hand-wringing definition. So machine learning is bad, it's stupid, it will kill everyone, it will take our jobs, it should be banned, it's dangerous, somebody think of the children. But that's not it at all. So it's not either good or bad. So I don't have a problem with anyone who is critical or skeptical about this stuff. I actually want you to be critical and skeptical. That's fine, and there are ethical concerns. Why? Because we are storing and sharing data, confidential data, maybe faces from people, biometrical data. So it's important to be aware of the ethical concerns. So to summarize this section, machine learning is not black and white only. It's not either yes or no, good or bad, wonderful or creepy, it will help everyone or it will kill everyone. No, there can be some places in between the black and white section for the machine learning and the artificial intelligence stuff. Something that needs to be completely clear is that machine learning is not a new way to solve familiar problems. If you see these two samples from mobile applications, let's start with the one on the right. In your banking application, if you have negative balance, you need to show that amount in red. You don't need machine learning for that. That doesn't make any sense. That's basic programming. On the left side, that's when you have to reserve a seat on a plane. You only select and that's it. You don't need machine learning for that. So I want that to be clear. So machine learning is a new way to solve new kinds of problems. And when I say new kinds of problems, I don't mean problems you have to invent or that you didn't knew before. So most certainly, these problems are things you have in your day-to-day situations, but you were not aware that you could use machine learning for that. Like what? Let's see. How much is a good price for a new product? If you see most of the business, they just put the price of the product. They don't see historical data, for example. How often should we send marketing emails? I see emails from promotions every week, every month, but is it a good recurrence? Maybe should these emails be sent at specific times of the day so you get more readers? Are there indications that our website is about to be attacked? And that can be done by checking the logs of the web servers, for example. And with machine learning, we can detect it. And that's something that Azure already does with the denial of service protection, for example. Is the discussion positive or negative? By reading just a text chat between two persons, we can also decide or define if the discussion is positive or negative. But what really is machine learning? What's the most basic definition of it? We take existing data, we analyze it to identify patterns, then we use the results to make better predictions about new data. That's the most simple definition that you can find. So, in the following slides, I'm going to make a simple exercise so that everyone understands what machine learning is. So we have this picture, and we have a reaction to this picture. So thumbs up, right? We have the next picture, a beach, beautiful, right? And a reaction, thumbs down. Okay. Next slide, again, some beautiful horses and the reaction, thumbs up. The next picture, fruits and the reaction, thumbs down. What do I want? Do I want the thing on the left, bananas, or do I want the thing on the right, horses? Congratulations, you already know what a classification algorithm is. By training our brain, we were able to know what I really wanted. And that's the same way with machine learning. For classification, of course, there are a lot more algorithms. So positive samples, you can see on the left, different types of horses, silhouettes, for example, and negative samples, you see them on the right, everything else. And that's a classification algorithm. So if we have this already in a machine learning model, so we can submit a new image to the model, and it will let us know if it's positive or negative. And that's a prediction, basically. Some classification samples. Incoming email, classified as spam or not spam. We can see already this on Outlook or Gmail, for example. Website activity, classified as high value customer or not. So if we have some traffic, we can analyze it depending on different factors from the logs and see if they are, if they will become customers or they are just browsing the site. Incoming attachment, classified as a contract or not a contract. And then you can prioritize that email, for example. That's something that can already be done using the Outlook add-ins, for example. Before moving forward, it's important to know what artificial intelligence is. Why? Because it's on top of machine learning. So the best way to describe it is machine learning is where we provide examples to learn from, but what artificial intelligence is where we provide explicit rules to follow. Let's go back to the self-driving cars from Tesla, for example. There is no way those cars can drive, can self-drive, let's say it, if they didn't train them with lots of data, lots of driving hours with a human inside the car and a human taking the decisions when to stop the car, when to slow down, when to turn left, when to turn right, things like that. So with this slide, I think that makes it clear for us. Let's talk now about Azure Machine Learning Service. The first slides were just pure theory. Now let's go to the practice. So Azure Machine Learning is a PaaS service with scalable on-demand compute, and that's just virtual machines that we can use to run the algorithms or train our models. There is integrated data storage and connectivity. We can create workflows with the designer as well. We can register every model that we train, and those models can be consumed by external applications via REST API or use Python SDK, for example. We can check the metrics and monitoring of the runs of those models, and we can deploy the models as endpoints. We can deploy those models either to Azure container instances or to Kubernetes as well. Let's go deeper into Azure Machine Learning. So the first thing that we are going to have is workspaces. So a workspace defines the boundary for a set of related machine learning assets. That's basically it. It's a group. And what do we have inside a workspace? First, we have compute targets for development, training, and deployment. We have data for experimentation and model training. We have notebooks containing shared code and documentation. We have experiments that we try, including the run history with log metrics. We have pipelines that define orchestrating multi-step process for complex algorithms. And we have models that we have trained. And the definition of model is the result of an Azure Machine Learning training run or some other model training process outside of Azure as well. A model is the most important asset inside Azure Machine Learning, because after you have the model, you can deploy it as a web service or you can consume it from Python code, either inside a Jupyter notebook or from another third-party application. From the logical point of view, so we have the Azure public cloud, we have subscriptions, and we have a resource group. And I think that's clear for everyone. Then we have an Azure Machine Learning workspace with the assets that we mentioned before: compute, notebooks, pipelines, data, experiments, and models. But when we create a new workspace, Azure creates a few resources for us: a storage account, application insights, key vault, virtual machines, and container registry. Okay, so those extra resources are created for us to support the machine learning workspace. So we have a storage account used to store files used by the workspace, but also to store data for your experiments. We have application insights to monitor predictive services in the workspace. We have Azure Key Vault to manage secrets as an authentication keys used by the workspace. We have virtual machines where we are running the models. And we have a container registry to manage containers for the deployed models. Okay. Now let's see some demos of this. So I am here in the portal. The first thing you need to know is when you want to create a machine learning workspace, you will see different services. Machine Learning Service Studio Classic, Web Service Plan, Web Service, or Workspaces. And this is the old experience. If we want to use the new experience that I want to show here, you use this one, the machine learning. Here, you can create a new one. I'm not going to create it. I'm just going through the wizard where you defined a workspace name, a subscription, resource group, location, and the SKU, whether it's basic or enterprise. In enterprise, the difference is basically that you can use AutoML and the designer, which is not part of this of this presentation. So, because I already have it created, let's go to the resource. When we click on launch now, we are going to see the new experience. Inside this new experience, we are able to manage all the assets that we were reviewing in a minutes back, right? The first thing, compute. Let's go to the compute option. Here is where you are going to create the virtual machines where you want to run your scripts. You can select CPU or GPU VMs. And here you have several different types of Azure VMs with different cores, different RAM, etc. That depends up to you and what you need. You also have compute clusters. So a compute cluster, it's basically the same, but it's not only one. You can set the minimum number of nodes and the maximum number of nodes, and you can set an idle seconds before scale down. If you have a heavy algorithm that is running, you can put as many nodes as you want, and after it finishes, it will slowly start to shoot down the VMs. If the VMs are not doing anything, they will be shut down, they won't be used. You can also have inference clusters. That's another type of virtual machines, and attached compute. In attached compute, you can bring your own compute, basically. It can be an HD Insights cluster, a virtual machine, and I mean an external virtual machine to the workspace, or Databricks clusters, for example. Then let's go to another option, datasets. So datasets you can create from local files, from data store, from web files, and from open datasets. If you are just learning, this is the best option. So open datasets are things that we can use and that are public for us. So, for example, New York City safety data. I provide a name to this, New York safety data, from which date. So I'm gonna put here 2019 until today. and we create the datasets. If we click on the dataset in the consume tab, you will see that they generate the code to be used in a Python notebook. So if I click here and I paste this and I run it, I can see the New York safety data as well. And then I can use it for my machine learning runs. Let's give it a second for it to finish. No questions on the chat? No. In the meantime, let's go to a different option. Then we have the models. So as I explained before, models are the main asset that we need to use when we create the experiments, right? So we have a model here, Keras MNIST2, and we have endpoints for the model. Basically, offline, what I did, because I don't want to show the entire script running, what we did is we created a script, we train the model, and we deploy it here as an endpoint. So I will show part of the code here. Let's see if this already finished. I have an error here. I'm gonna ignore it for now. So I have this script here. This script is getting started with Azure Machine Learning. That's in a GitHub repo for free. You can download it. We use Python. We import the machine learning call package. Then we get the configuration for the workspace. Then we run algorithms. I'm not going into the specifics of this code. We see the experiment results, and that's basically it. So I don't want to go into the low-level details of running the experiment. Then we have training models. So after we run experiments, that basically means we are doing some tests with our data in a low scale. So we are not using the entire data sets, and we are now sure what we want to do with that data. Then we create a training script, and that will generate a model, right? So in this sample, I was using the diabetes CSV, which is an open data set. And after I need to drink some water. After the script runs, we have a model that you can see here, and we are using for that model the logistic regression. Some people ask me if we need to be statisticians in order to run machine learning. And that basically depends. There is extensive documentation in the Microsoft website and in others in order to know what all this function does without being an expert on mathematics. So yes, you need to know the basics, but not what it's doing inside the algorithm as well. Okay, once we have the model, we will see it here as a model. Then we can deploy it. The deploy of the model is basically what we are doing is we are exposing the model to be used from the outside world as a REST API or as a Python script, for example. In this case, I already did it up front for another model, and I think is this one, deploying model. So in the Azure, in the GitHub repo, there is a full sample about recognizing handwriting numbers. So we train the model with different numbers, handwriting numbers, and at the end, we want to predict if somebody is writing that a number in a piece of paper with his own handwriting. We want to predict which number is it, right? So there are two ways to use that model in code. One is with the SDK, with the Azure ML SDK. So here we have some test samples, and we are using one image to be predicted, let's say. So the image is in JSON data, which we are just deserializing to JSON. And at the end, you can see in the notebook the predicted value. It's important to know here the certainty or the probability. That basically says this is 99.95% sure that is a number 9 here. Okay, and you can see in the result there are other numbers, 0, 1, 2, 3, and you can see the probabilities here are way lower than for the number 9, right? But we can also test it via HTTP, and that's just doing an HTTP post request to a specific URL with some data, with some headers, but the response is basically the same. So here I have, for example, the number 4 for another test data that I sent, right? And that's basically it. So we create or import data sets, we create notebooks to run experiments. Once we are happy with the experiments, we create a model and we train it with Python. And once we are happy with the model, we can deploy it as an endpoint. In future meetups, we are going to talk about automated ML designer and pipelines, for example. Now, let's go back to the presentation here. So what's the value of machine learning? Use a 3% improvement in detecting gift card fraud, resulting in 40 million loss avoidance. So only 3%. They didn't even have to detect 100% of the gift card fraud. It doesn't have to be perfect to be valuable. As you saw, there is a probability in the results, and the probability is probably never be 100%. Most of the times it can be 99%, 98%, and values like that. So it doesn't have to be perfect. And Microsoft vision for machine learning is make it accessible to every enterprise, data scientist, developer, information worker, consumer, and device anywhere in the world. And I think they are doing a great job with the new machine learning workspace. You have in one portal everything you need. It's important to note here that we can also use VS Code, for example. VS Code, there are extensions to connect to the machine learning workspace. So if you don't want to work inside the browser, as we were doing it, you can do everything in VS Code as well. You can run the experiments either with your own compute in your own computer or laptop, or you can do it remotely in the VMs. So machine learning is basically focused on predictive analytics. It's important to know that the first credit scoring was used in the 1950s, for example. So machine learning is not really something new. Today, it's more accessible to everyone, but in the past, it was already being used. So what are the three fundamentals of machine learning and predictive analytics? Speed. We can evaluate millions of customers in seconds. Accuracy. It's more accurate than humans, between 20 to 30%. And consistency. A machine learning algorithm does give the same results whether the time of the day or whether, well, machine learning is never going to be hungry or not. But what I want to explain here is that the human fields can have different outputs, different outcomes on a decision that can be done by a machine learning model. Some use of predictive analytics. So, for example, identify people who don't pay their taxes, calculating probability of having a stroke in the next 10 years based on your alimentation, for example, or based on the workout schedule you do. Spotting which credit card transactions are fraudulent. Selecting suspects in criminal cases, deciding which candidate to offer a job to, predicting how likely it's a customer will become bankrupt, predicting which customers are likely to defect to rival phone plan when their contract reaches its end. Something that we can see already in the market. Determining what books, music, and films you are likely to purchase next. And this we can see already in every web store like Amazon, right? Forecasting life expectancy is another example. Where to learn money. So docs.microsoft.com/enus/learn, you will see lots of training already. You can filter on the left with machine learning service, and then you can decide at your own pace what you want to study. So let's see if there is any question in the chat. Any question? I will give it a minute. Erwin? Yes, you can unmute.
Yes. Hello. Can you hear me?
Yeah.
Yeah. Thank you, Valencia, for the presentation. I have a question mainly on one of the sentences that you wrote where it says one of the goals that Microsoft has is to make machine learning accessible to every enterprise, data scientist, developer, information worker, consumer, and device anywhere in the world. So one of the major blocks I see in having something like this goal is the fact that, number one, not everyone can program. I mean, the Jupyter notebooks and all that is great. There's still a lot of clicking if you're going to spin up instances and all that. So my question is, in this goal, I hope, okay, in this goal that where Microsoft is trying to make machine learning more accessible, one of the ways that you can measure that is to, number one, reduce the number of clicks in order to generate a model, also to reduce the amount of coding that you need. For example, there are two. I mean, AutoML. There's Python AutoML packages, but then you can easily do that via clicks instead of coding.
Yep.
With tools like Data Robot, H2O, and all that stuff. So what I was somewhat hoping to see that kind of distinguishes Microsoft as an organization from the other two big competitors, AWS and Google, because what you showed today, it was great, but it's something I can easily find on AWS and Google as well. They have equivalents,
Yep.
they have similar equivalents there.
Yep.
So my question is, but one standout point that Microsoft has is the fact that a lot of big enterprises, a lot of corporates, they still use the Microsoft package, be it Outlook, be it Excel, be it Word, be it Microsoft Teams. And so my question is there going to be integration in those tools, because they already exist in a lot of enterprises, to have less clicking and less coding, so that people like the information workers, the consumers, the devices, people on just a mobile phone, they can have better access to machine learning? That's my question.
You mean in the Microsoft suite, basically, in the Office suite?
In the Office suite, yes, because that's one area which I see Microsoft having a foot up, so to speak, an advantage over Amazon and Google. So the question is, are they leveraging the Microsoft suite to make machine learning more accessible? Or if they're not trying to leverage that, then can you explain a bit exactly what strategies is Microsoft undertaking to make machine learning more accessible to people in general?
I can't really talk for Microsoft, but basically I'm not a Microsoft employee, so maybe Nick. Yeah.
Let me respond to that one, Luis. So yeah, this is Nick here. I'm a Microsoft employee. So basically, going back to your question, so when we say that we want to kind of democratize AI and machine learning, we kind of hint to multiple profiles. So one is, of course, the developer who does not really have any experience with machine learning models and algorithms and even Python. And so for those people, we have solutions which are still, as you referred to, they require some clicking, but still they kind of remove kind of the hurdle for knowing all of the intricacies of machine learning. And so there are tools like ML.NET, which allows you to do machine learning in an easy way as a .NET developer, without having to know all of the algorithms in Python. Then there is, of course, stuff more like the visual designers. So we have the visual designer in Azure Machine Learning Service. There is AutoML, which will kind of do all of the automated calculations and selections of the models and some featureization. Again, targeted more towards a technical audience. Now, coming to your question specifically around how do we kind of democratize AI in where we are really strong. In terms of the enterprises and information workers. So there we have, again, there is AI already integrated in some of our Office applications, more in the sense that you use AI. For example, in PowerPoint, you will be using AI when you have, for example, the designer propositions. When you create new slides, all of that is based on AI. There are in Excel capabilities for basically using machine learning technology, but more towards, more behind the scenes. So that is more from a user perspective in the Office suite. But if we then look at how can you build an application as kind of a power user, there we have the AI builder, which we have integrated in our Power Platform, which allows you basically to have more from a business perspective, where you say, this is my data, I want to do forecasting, and it will automatically do all of the nuts and bolts and everything behind the scenes for you to get, for example, a sales forecast in your application based on your data set. So it is kind of a further evolution of AutoML, but then more towards a power user or an information worker rather than a developer. And so there we typically you would be looking at the functionalities that we provide as part of our AI builder kind of technology. And similarly, you have that functionality in our Microsoft 365, so Dynamics suites as well, where there is AI integrated within those products. Does that kind of give you some? Does that answer your question to some extent, Urban?
Yes, it does. To some extent, yes. I guess I was just hoping to see a bit more, because I mean, for example, from a perspective of, for example, if someone, you know, a normal employee that doesn't know anything about computer science receives an email with an Excel file on Outlook, it would be nice just saying to, you know, have a click and then they can generate the forecast, for example.
Yeah, well, that's functionality that we have as part of the AI builder.
Okay.
Where you have where you basically have where you take your data and it will do everything for you to give you that forecast.
And that's part of the Office 365 package?
That is part of our Office 365 package.
Yeah, I will take a look at it.
Part of our Power Apps functionality.
Yep, I will take a look at it and hope I can click and get access to that.
Here. Already, you could take a look at it.
Okay.
Thank you.
Okay.
Yeah. Thanks for your question.
Thanks, everyone. Nick, the floor is yours.
Yeah. Could we just have like a 5-minute break?
Yeah, sure.
Thanks for joining this second session. So I'm Nick Throgh. I'm a Azure Developer Engagement Lead here at Microsoft. I'm based in Belgium, but work for like the Western European team. So I cover different countries depending on the topic of interest. And so my main expertise lies in AI and machine learning solutions at Microsoft. And so what I do typically is engage with developers and all technical people wherever they are. To explain them what you can do with Azure machine learning experience. So yeah, Luis already went into some detail on the different kind of scenarios that you can tackle with machine learning. How is it different from pure programming? One thing I wanted to start with first is kind of an interesting case that we have worked on in Microsoft. Which is, let me switch to this one here, which is more of a, which is part of our AI for Good solutions. And it is actually a solution that we built together with people from South Africa, where they actually see huge problems with poaching happening in their national parks around rhinos. And so they looked at,
are you sharing something?
Excuse me?
Are you sharing something?
Yes, I should share my desktop. You're not seeing the desktop?
Only Teams.
Okay. Sorry for that. I'm going to share the full screen. Is that better?
Yes.
Okay.
Yeah.
Let me switch to this one again so you can get my Twitter handle. Okay. So yeah, as said, so it's a project that we worked on with the Peace Parks Foundation in South Africa to prevent rhino poaching through a solution based on machine learning, because these parks are so gigantic and they really have an issue with poaching of rhinos there. And here you can actually see that every day there's like 3 rhinos that are being killed for their horns, for their and so that's a huge problem. And so they looked at, is there a way to use technology to kind of solve this, or to make at least an impact and to reduce the problem? And so the main thing that they wanted to do is actually being able to identify these poachers. So in these national parks, they are so gigantic, so it's really hard to get somebody there, to get those park rangers be at every single spot where there are rhinos every single day. And so what they want to do is they want to be alerted whenever people are being identified in those national parks. And so they want to get an alert as soon as possible, and that is within 2 minutes of the event occurring, of a person being identified or multiple persons being identified. Get basically an alert of where are they, how many people were there, and actually get the evidence as well. Get the picture of those people, so that those rangers can immediately take action or just dismiss a specific alert. And so for that, they're using these camera traps. So these are basically IoT devices to some extent, are cameras that take pictures and are used using motion detection to actually take pictures of things happening. And so what happens is all of those photos that are being taken by these camera traps are being analyzed. And so what they want to do is they want to have like an cheap and easy to maintain solution in those parks that are able to rapidly detect suspicious human activity. So basically detecting humans in those conservation areas and send out alerts, as said. There are of course some challenges. It needs to be it can't be super expensive. These foundations run on a limited amount of money. It can't be too complex because running IT is not their main and their core business. They run parks and conservation areas. They don't run IT, and it needs to be tolerable for faults and for connections dropping, because they're using some third-party services as well to send out the alerts. If for some reason or another there's something which is down, which can happen, you're in the wild there. Things need to be fault tolerant. Of course, all of the other issues like privacy, security, etc., need to be there. Also, there are of course lighting conditions that you need to take into account. It's not just happening during the day, also during the night with low light scenarios. Make it even harder to identify that there are people walking around there. And so as said, they are not running any server infrastructure. So we need to look at a solution which is as easily maintainable as possible. And so you'll see in the kind of the architecture that is also a key property of the solution, is that it is easily maintainable. So the objective of the machine learning service that is integrated in this full solution is to be able to detect people in those different conditions. And they want to have a high recall, noting that they should be able to, they can't miss any people, preferably, because there are not that many rhinos. So if you miss like 10 people walking around, that could be devastating in terms of the impact on the population of rhinos. So you need to have a very high recall percentage. And of course, they don't all want to flood the system either with false positives, because if these rangers get false positive many times a day and at night, they'll start ignoring those as well. So that's a balance that we need to find there in making sure you don't have too many false positives, but still have high recall. Those are kind of some of the things that we needed to work with. Then looking specifically at the machine learning model that was being used, the algorithm, don't gonna want to go into too much detail of this one. What we did, we compared multiple algorithms for doing these, for doing object detection. And the one that came out best at that time was the RetinaNet, which is a convolutional neural network, as pretty much most of the vision algorithms nowadays are. And so that was kind of the underlying machine learning algorithm that was being used. And so that was identifying what happened. And so here you can see some visual results of identifying a person either during the night, during the day. Also here you could see the actual alert, a screenshot of the alert system, where this is kind of the message that was being sent to those park rangers, where they actually get the picture of, well, they get the actual picture sent by these camera traps, and they also get some metadata. Where was the alert generated? How many people were counted there, etc., etc. So that's kind of the experience that they got. Now, how did we build this, or what were kind of the technologies from a very high level perspective? Because I can't go into too much detail on this one. The information is not yet made public, and so on the left hand side you could see the camera traps. So these connected devices which will be sending photos. So as soon as they kind of trigger any motion detection, they will send the picture through email. So these cheap devices, you basically need to have an as cheap and as reliable solution as possible. So you can't go there with high-tech camera devices. Either they get stolen or they break easily in those harsh conditions. And so these devices send their pictures through email, through the backend system. And so for that, the SendGrid solution is being used with a webhook that will trigger basically a number of Azure functions. So Azure functions are our serverless solution. So for people coming more from an AWS background, that would be Lambdas. And so they give you basically the functionality of serverless functions, which in the first instance will process the email. So it will look at the email with the photo in there, store the photo in blob storage, store the metadata in a Postgres SQL database. Again, a managed Postgres SQL database. They don't want to manage infrastructure. These functions as well are serverless, so no management of infrastructure needed there. Again, all with the purpose of making this as easy as possible. So we're processing initially the message, and then comes kind of the key part of the solution is processing the image that we received from the camera trap, and this will actually invoke our scoring service, which will in turn be based on the RetinaNet implementation. And so all of the scoring service is exposed as a web service which is running on Kubernetes, a managed Kubernetes service. So the AKS service within Azure. Yeah. And so the whole deployment and the actual continuous integration, continuous deployment cycle is being managed through Azure Machine Learning Service and Azure DevOps. Yeah. So Azure DevOps will basically make sure that we have CI/CD up and running, and it will integrate with Azure Machine Learning Service to do all of the model training and the model deployment to Azure Kubernetes Service. Okay, and so based on the scoring results, there will be either the message will be either ignored because there are no people identified in there, or an alert is being sent back to a park ranger or whoever may be needed to be alerted. Okay. So that's kind of the high level setup of this solution. So pretty much all of this is easily maintainable from a customer perspective. Yet still we have all of the flexibility for easily retraining, updating, and deploying of the machine learning solutions. Okay, any questions on this one? Because I can't see immediately here. No. Okay. Do interrupt me if you have any questions. Okay. So we used Azure Machine Learning Service, as said. So here, already as alluded to by Lewis, is
sorry, Nick.
Yes.
Erwin has a question also.
Oh yeah, sure. Yeah,
sorry,
Erwin.
Question. Yeah, thanks for the presentation. I have a question regarding this particular situation. It seemed to me that the limitation is on the rangers manpower.
Yeah.
Right. So was there any when you're generating the thresholds on whether or not to send the photos, was there any you keep in mind the fact that like you said, you don't want to overload them, but at the same time you don't want to not send them any information neither and have them sitting in the hut drinking beer all day. So any consideration about that?
Yeah. Well, there, of course, that's taken into consideration. You are indeed depending on humans to actually take action, and so indeed you need to be diligent in how you do this. One thing we did is, of course, much relies on your data set. So the bigger and the more accurate your data set is, of course, the higher your accuracy of your machine learning model will be. And so the thing we did is we got, I think in terms of data sets, we get thousands and thousands of images being sent in through these cameras. And of course, the data is highly skewed because pretty much the majority of the images are just a landscape and maybe some animals in there, but basically no people. So you have a very imbalanced data set. And so what we did to basically parse through all of those data is that we actually used machine learning as well to do the actual tagging, to make the tagging more efficient, and basically be able to process as much data as possible to make our data set or to make our model as accurate as possible. The only thing you can do to counter or to achieve those objectives of high recall, so not missing anything yet still have low false positives, is that you need to have an enormously big data set. And so again, there you also depend on people, and so that's something that we wanted to avoid is how can we automate the actual tagging process and the labeling process of the data, and for that we use the machine learning model as well to kind of speed up that process and be able to have a good data set. Apart from that, it's really hard to get. There's no silver bullet for this, which I think you already knew as well.
I used to deal with fraud detection. I guess my question was mainly, do you adjust the threshold based on
well, there is indeed
the ranger's manpower?
There is indeed some balancing that need to happen. The threshold, as it was said, that's something that you need to balance all the time, or well, at least in the beginning, in the first couple of months, you really need to tweak those thresholds based on the actual data and the experience that you get.
And is this done, the threshold adjustment, is it done dynamically, or is it something that you do every time you retrain the model?
That is, if I'm not mistaken, that is done through retraining the model.
Okay.
Yeah.
And I don't know anything about rhinos and hunting, but is it seasonal? Meaning that the hunters appear more during Christmas? I don't know.
As far as I know, not well. There's probably, well, there are of course there is some seasonal impact, of course, due to weather conditions. Although South Africa is not that does not have those kind of extremes in terms of bad weather versus acceptable weather. There are some slight differences, but overall there are no big seasonal impacts on these rhino poaching happening. No.
Okay. Good.
It's
Thank you.
Yeah. Okay. So this, some background on a nice project we did. Indeed, something which is somewhat atypical and not your typical. Well, typical. It's not that typical fraud detection, but still, it's somewhat more exotic. Let me put it that way. So coming back to the machine learning process. So Louis already went into some of the topics I wanted to go a bit deeper in, and so we'll look at Azure Machine Learning Service and some of the capabilities. So one thing I wanted to do is go a little bit deeper into the Python SDK. So how do you integrate with the Azure Machine Learning experience as a data scientist or as a data engineer? So what are kind of the hooks that you can leverage to make use of Azure Machine Learning Service capabilities? So that's one. And then second, I also wanted to give you kind of a view on the visual experience. So the actual visual designer as well as the automated ML, if that's okay for you. Okay, so I think this is already clear. So the machine learning service is a set of cloud services. And key there is, and that's the part where we'll dive into first, is the Python or an R SDK that will allow you to basically tap into these Azure cloud services. Because one thing that we wanted to do is make Azure Machine Learning Service agnostic of your development tool, of your language, as well as your framework that you're using. So it should be able to go with all of these tools, languages, and frameworks, still give you all the capabilities of managing your machine learning lifecycle. And so that's why we have these SDKs that allow you to tap into these. Rather than going into here a lot of explanation, let me quickly go into a demo. So you saw this. So this is the Azure Machine Learning portal experience. So the notebooks that you saw from Louis. So one thing I wanted to show you here is go a little bit deeper into the specifics of integrating. So as mentioned, so the cornerstone of integrating with Azure Machine Learning Service is, of course, the workspace. So everything depends on the workspace, which has a number of experiments which have their specific runs. And then to be able to run those experiments, well, you need compute. Which could be local, so it could be your notebook. In this specific case, we will be running the code within the Jupyter Notebook. Let me switch to the Jupyter Notebook experience. Maybe that's more recognizable. And so here, basically, we have our workspace. And so first, we need to connect to our workspace. We'll get this from the configuration file. How do you get this configuration file? Either you create it yourself, or it will actually be generated for you as soon as you log in here and use it for the first time. It will come and ask you which is your Azure subscription that I need to connect to, what is the workspace that you want to use, and it will save all of that information into a config file, which you can then use wherever you need it in your Jupyter Notebooks or in just any Python or R code that you may have. You don't have to run this in a Jupyter Notebook, by the way. So we get our workspace, and then after our workspace is kind of connected, we will be creating an experiment. So an experiment, as said, depends on a workspace, and you just give it a name. So this is just a logical kind of container for your experiment. All of those will be versioned. But this is also the nice thing. As you go through multiple experiments, you want to have versioning in there. And you want to be able to track differences between experiments. You want to come back to previous experience that you did, as well as runs that you did. Okay. So this is your experiment. And once you have your experiment created, in this specific case, created, or it will connect to an existing one if that name is already existing in your workspace. And then happens, of course, the standard Python code for your machine learning model. In this specific case, just a diabetes data set. We're going to get our training and test data. So we'll just do a standard test split, sorry. And then we'll go and train the model. Yeah. Training the model is, again, this will be very familiar if you are used to using standard machine learning algorithms. So the classical machine learning models, like here using a rich, is basically what we're going to do. We give it an alpha value. And one thing which is specific here, where do we actually integrate because this is all fairly standard machine learning training code. So where we start integrating with the machine learning service is these two lines here. So we do our experiment start logging, which will actually start keeping track of whatever happens in your training of your machine learning model. And it will allow us to kind of log specific values. In our specific case, as we will be looping through multiple, so we'll be doing multiple runs. So for each of these alpha values that we have, 0.1 until 1.0, for each of these values, we will be creating a new run. So a run is basically an execution of an experiment with specific values. And so whenever we do start logging, that basically signals that there is a new run starting. Whenever we log something, that specific value will be logged as part of our run. And then finally here, we're also logging our error value so that we can validate then which is the best set of values that we should check for. So which is our model with the highest accuracy. And then finally, we're going to upload the actual trained model. We'll give it the model name here. We're going to upload that specific model to basically our run within our workspace. So again, this will allow us to keep track of trained models and then just grab the one which gave the best results. Doing a run.complete just finishes off this specific run. Yeah. Okay, so this piece of code will actually train our model and save every single iteration, so every single run in the portal. Not going over the actual running, but I do want to show you what it looks like if we have such an experiment. So we have our diabetes experiment that I ran previously. And so there you can actually see those 10 runs that happened for each of the alpha values. And so here we can actually see our alpha values going from 0.1 all the way to 1, which is the values that we provided. We can see them in a graphical view as well, how they actually get, how they evolve. And so here we could see that basically this is the first iteration gave us the lowest error value. So we can go and navigate in here. We can see how long did it take, etc., etc. We can see our metrics. In the outputs, we should be able then to see our actual pickle file. So our trained model is part of this one here. And so we could, if needed, we could actually download this model as well. Yeah, so if we say here download, we can actually download that specific file. And then, for example, package it up in a web service. Okay, so that's kind of the basic experience where, going back to this one here, where we run or where we execute a specific experiment and have, in this specific case, we have 10 runs happening with different values of parameters, of hyperparameters in the specific case. Okay. So then how do we get programmatically the best model? Because yes, we can look in the portal and see which one is the best. Well, actually, we can, again, integrate with the machine learning services, get all of the runs, we can get its metrics and the actual details. And then this is just finding out the best, the one with the lowest error value. And then will give us the specific best run ID, which will then in turn allow us to get the actual best run. And then get its file name, which is basically this one here, the one I showed you there. It allows us to get that file, and so we can actually do best run.download file. Yeah, in the same way you do it in the portal, you can do that programmatically, and then you would use this specific pickle file then to package it up. Okay, so that's kind of the basic experience. If you run all this in this notebook, all of the training, all of the code will be running within our Jupyter notebook. Yeah, and we'll be running on what Lewis also mentioned. If we go to compute, so these notebooks actually run on what we call compute instances. So these are kind of prepackaged, managed environments. So they're basically Linux VMs that we manage for you. So you have no infrastructure to manage for these. They already have a whole bunch of frameworks pre-installed for you. So for example, TensorFlow, TensorVision, PyTorch, all of those are already installed for you, so you don't need to pip install them on those machines. However, you can if you want to. And so you get direct links to either Jupyter Lab, Jupyter, or an RStudio environment straight from within here. Yeah. Or you can do an SSH session as well if you want to have just a console access to those training environments. So these compute instances typically are being used for running your notebook experience. However, you can also use them for regular training or even for inference. So you can deploy your trained model on a compute instance and then deploy them as a web service and invoke those web services just on that compute instance. So if you're really in a development environment, you can do so. In a production environment, I would not recommend it, as this is just a single instance. It is being used also for your notebooks. Someone can easily switch it off or restart it. So don't really use it in production for doing your inference of your trained models. So that was kind of the basic experience, your notebook and running your training locally. But still integrate with Azure Machine Learning Service for the sake of logging your experiments and all of the runs that are happening. So you still get all the backend of Azure Machine Learning Service, but you're not really yet using all of the compute capabilities of Azure Machine Learning Service. So in the next one, the next quick demo I want to show you here is where you start looking at using Azure Machine Learning Service basically for running your compute, your training on compute clusters. So going back here to our compute view here. So in our compute cluster, you can actually see here that I have created two of them. I have a CPU cluster and I have a GPU cluster. Let's say, for example, this one. You can specify basically how many, so these clusters are auto-scaling. Again, they are managed by us, by the platform. So you don't need to deal with the actual machine and installing things in there and spinning up new nodes. You can actually look at here. I have a standard NC6 machine, which has a minimum number of nodes of 1 and a maximum of 3. And it will idle after 120 seconds. It will just turn them off if that is needed, and for saving you costs. You can also set the minimum number of nodes to 0 if you want to avoid that you have costs incurring while you're not using your cluster. Of course, whenever there is a run that needs to happen on that cluster, it will take some time to spin up that machine. Of course, if you put it at 0, so it needs to spin up that first one. It will auto scale between your minimum and maximum number of nodes, so automatically. So these you can change at any time as you feel like. So how can we use these compute clusters? So here, basically, again, we have the same experience. We're going to load our workspace. We're going to create an experiment. And then basically what we're going to say is, in this specific case, we can actually connect to an existing compute target, so compute cluster. So just by referring to it by its name, so in this specific case, we're referring to the CPU cluster, and we're going to check, does it exist? If it exists, all good, we're going to use it, and then that is part of our compute targets. If it does not exist, we can actually create a new one, so we can provision a compute cluster if we want to. We can specify the VM size, a number of nodes, minimum, maximum. You can have a more advanced experience as well, where you specify a lot more parameters as you feel like. Yeah. And so once we have that, we have our configuration, then we can actually create that compute target based on this configuration, then wait for it to be completed, and then just show our status. So this is just creating our compute target and linking it to our workspace. So we'll have workspace.compute targets. We will have one in there that we just created, or that we just refer to once if it was created before. Yeah. Now, how are we going to leverage that compute cluster? So again, this is the MNIST example. This is just showing the data. How are we going to train on this remote cluster? So first, I think Louis mentioned this as well. So we need a train script, because this the code here is not going to run within our Jupyter notebook. We want to have our training script be moved and be copied onto our compute cluster as soon as we kick off a training job. And so how are we going to do this? So we create a standalone training .py file. So this will be written here locally within our Jupyter environment. And then what we're going to do is we're going to create what is called an estimator. Yeah, so we specify here first an environment. The environment will specify what are our Conda dependencies, what are pip packages that we need to install. So all of the dependencies will be specified. So whenever we have a training job that needs to run, it will make sure that that environment is prepped using the dependencies that we want. So this is what is specified in this environment. And then once we have this environment, we have our training file, our train.py file. Then we are going to create an estimator. So an estimator allows you to easily kick off a run of an experiment. And so the estimator gets the folder where our scripts are. It gives some parameters. It will specify which compute target it needs to run on. It will get the environment parameters, so the dependencies for Conda and pip. And then it will get our training file as well, which will actually do the actual work of training our machine learning model. And so by submitting our estimator, so we give it our estimator, it will actually run that training job not within our Jupyter notebook, but it will run on our compute cluster. Okay, so we can get some details. We can have a Jupyter widget that will continuously refresh as long as the job is running, and basically that's what we get. Okay. So once our run has finished, we can actually, again, as we did in the local run as well in the previous example, we can get the metrics, see basically what was the, in this specific case, regularization rate, what was the accuracy, so close to 92%. And then the second step we're doing here, so we have trained our model on our compute cluster. We're actually going to get file names. So we need to get our pickle file, which we should be able to see in here. Yeah, there you go. So the pickle file is part of the file names that were saved as part of our run. And we are going to register that model. So registering the model actually puts it in our model registry, so which is basically a version control system basically for your trained models. And that registry is basically agnostic of which type of framework you're using. So in this specific case, we grab this pickle file from our best run and we save it in our model registry. And so we can go in here in our machine learning experience, we can go to our models, and we have here an scikit-learn MNIST version 2. You can actually see there's an MNIST version 1 as well. So as we put multiple versions in there, we can always revert back to a previous version if we want to, or we can go to the one that was uploaded here. And so there we can actually see the details. So metadata, when was it created? What is the framework that's being used? We can have some artifacts in there, artifacts which will be, in our specific case, will be our pickle file. Potentially there could be other things in there as well. And as soon as we are going to deploy this service, which Louis also mentioned there, you will see an endpoint being displayed here as well. So to get from a trained model all the way to your deployed endpoint, all in this single interface. So you can tie the two together, which is basically for your auditability. You want to know which version of your model is deployed to which endpoint. And so that's the experience that we want to give here. This is taking a little bit of time. And so here again, you can see your pickle file. That is part of your model registry. Yeah, so with multiple versions that we have there. And then in kind of the third step, so once we have our trained model, we're going to deploy it as a web service. So deploying a model as a web service basically means that you are going to create a scoring file. The scoring file, which will actually be wrapped for Python, that's going to be wrapped into a Flask application and will expose two methods, basically, two functions. So first is the init function, which is called once when the service is first invoked, and it will do all of the initialization of the web service. So typically you would load your model here, do some pre-initialization if needed, and then we'll have the run function, which is executed with every single call to your web service. And so in this specific case, you're doing the actual inference. So you'll do the predict in our specific case. You'll have model.predict based on the data that was fed through the web service as an input parameter. So as part of its body for the post request, because this is responding to a post request and takes the body, which will be a JSON document in our specific case. So we create this scoring file. We create a deployment configuration file, or we create a deployment configuration, not a file. We need to specify actually where we want to deploy this web service on. And so we can deploy on Azure Container Instance, which is kind of a serverless model for running containers. So you actually give it just a Docker file, and Azure Container Instance will spin it up and manage that for you. So you don't need a cluster. You don't need to spin up a VM which is capable of running Docker. So you just give it a Docker image and it will run it. Yeah. So these are container instances. Just as well, you could have an AKS, so a Kubernetes service deployment. So this is what we use for our project there for the Rhino poaching, is we deploy to a Kubernetes service just for the scale of things, where we needed to have a more, let me put it, a more performant or a service which allowed us to scale out more rapidly than ACI. And so we have our deployment configuration. So we specify how much CPU do we need, how much memory do we need, maybe add some tags in there, and then we can actually spin it up by doing a model.deploy, giving it the configuration. We give it the scoring file. Also, we give it some environment data, and that will actually deploy our scoring file and package it up in, as I said, in this specific case, make it into a Flask application so that we have a REST endpoint that we can invoke. And so we'll have a service which is listening at a specific URI. In this specific case, it is anonymous. You can also secure it with HTTPS, which you should be doing in a production environment. This is just for the sake of demo. And then you can actually run, execute this service, either by calling just service dot run, or you can actually invoke the HTTP request directly as well. So you have two options. Either you use the Python SDK for calling your service, or you just go through the HTTP endpoint. I realize I went a little bit quickly over that one, maybe. Any questions so far? Let me switch to Teams here. Nope. Are we all good?
I have one.
Yeah, go ahead.
For the Rhino poaching,
yes.
For the training, did you have to use a GPU instance, or did you use the Vision API or something like that?
No, we used, it was a custom model. So we used so the RetinaNet, and we ran it. We trained it on GPUs.
Okay.
Yeah, it's a CNN, so convolutional neural network, which highly benefits from training on a GPU.
Okay.
Also, because of the size of our data sets, it was not something that we could actually train on CPU. Just for time.
Okay, thanks.
Yeah, thanks. Okay, so that's kind of a little bit of an overview of the Python SDK. So how you integrate in it. So basically the core, the bulk load of integrating with Azure Machine Learning Service is pretty simple. It's pretty limited in terms of what you need to add to your existing training code. And that's also something that we wanted to have, is that it should be as less impactful as possible, to make it as flexible and as agnostic a framework as possible. But now I wanted to go to the more visual experience and just quickly take you through kind of, if you are more on the developer side of things, and you don't want to write any custom machine learning code as part of your project, and so you want to either go through the designer experience, which will kind of give you a canvas where you can just drag and drop the capabilities that you need. So let's say I want to create use a compute targets. Let's take the CPU one, which is already running. There we go. So we specify where our machine learning model is going to run on. So the training part as such. And so we're going to take an existing data set, and for this one I just want to do a regression problem where I want to do a prediction of the price of a second-hand car. It's a very traditional one and an easy one because I don't want to focus too much on all the complexity of the model itself, but rather give you kind of a view of the experience of this this visual designer. And so what we're going to do is we take our data, and then of course we need to select some columns in our data set because not everything is relevant, and so we want to kind of remove some of the columns from our data set. So this is what's happening here. So select columns. We can just connect all of the boxes, then say edit column. So which one do we need? So we start with including first all of the columns. And then what we're going to do, we're going to exclude one of the columns. And let's say we want to exclude the normalized losses because that is already a calculated value, which we don't, it's not relevant for our training of our model. So we're doing this one. So we're removing this one then. And then what we need to do is we also need to know, we need to clean some missing data because we know our data set is not 100% clean. And so we're going to add some logic in here. So in the sense that we are going to include all columns. So we're going to basically, very simple approach here, just remove all of the rows which have missing data. And so either we can replace the missing data with some average or some median values, but in this specific case, we're just going to remove that entire row from the data set. So this is basically our data preparation part. Yeah. So here I've just shown like pre-canned boxes and activities that we have here. Just as well, you can insert a custom Python script. So if you have some custom Python for doing your data prep, you can just tie this one in and then put your Python script in here if you want to. So it is extensible or customizable beyond just the standard activities that we have here. Now, after we've done our data preparation, we of course need to start doing our training. And the first thing is, well, we need to split our data. So in training and testing data, so we're going to split and we'll take a 70% training data, 30% of testing data.
I want to mention something there.
Yes.
And by seeing the toolbar on the left is that you can combine Python and R into the designer basically.
Oh, yes, indeed.
And that's very great because I see a lot of statisticians creating package in R, but
yeah, indeed.
almost everybody is learning Python instead of R, but then we can reuse it.
Yeah, indeed. Whatever you have indeed created before, you can still reuse indeed. If you have some R code lingering there, you can still use it. Yeah. And so now comes basically the actual training part. And so we decide on what algorithm are we going to use. So you get out of the box a number of regression, clustering, classification algorithms out of the box. Or you could use your existing R packages for this. Then we're going to train our model. So again, training our model, our trained model takes a specific algorithm as input, and then it takes, of course, some training data as an input. It connected well. There we go. Then, of course, we need to score. So we're going to look at how well is our model doing. So we're going to take the output from the training. We're going to take our test data, so our validation set from our split here. So the 30% is coming in here. You can see here we missed something. Obviously, when we train a model, it can't know automatically what column we want to calculate. And so we need to specify our label column. In our specific case, we want to predict the price value. So we can get this one in here. Let me move this one up a bit. So we score, and then the final step is there. We are going to evaluate our model, basically looking at what is our, did I copy here? So what is the actual score? What are the error values for our model? So one thing you could do in this specific case, I'm just taking a single model or a single algorithm. You can actually chain multiple ones. So you could have, for example, not just a boosted decision tree, but you could have, for example, a linear regression as well in here. And then we could probably this one here. Connect this one in here. Then you would have another scoring module to score our linear regression. Training is already set to price because we copied that one. And then our second scoring will feed into our evaluation. And this will then allow us to compare both the linear regression and the boosted decision tree. And then we can decide which one is the best, after which we can then deploy that specific trained model as a web service. Again, all of this, once we do submit, it will train this model on either our compute cluster or our compute instance that we specified at the beginning. And then once it has been trained, we can then specify where we want to deploy this model to. So this is kind of the visual experience where you kind of you know a little bit about machine learning, but you're not familiar with writing all of the Python code, or you want to do a quick experimentation here without writing a lot of code. Well, you can do it through the visual interface to get kind of a quick result, just to do your initial validations, and maybe then you can go to a more code first experience. Probably I should have. One thing I missed here is we need, of course, connect our validation data to our scoring model. But this is kind of the visual experience that you have here. And so the deployment itself is going to allow you to then to expose a trained model as a web service without writing a single line of code. So this is designer first versus the notebooks, which are code first experiences.
We have 2 questions in the chat.
Yes, let me switch. Yes, let me see here. Another question here. How do you push the model to production and do A/B testing, for example? So pushing it to production. Do you mean through the designer, Urban?
Yeah, if possible. Is it possible to push it?
Yes. So let me take one, otherwise I'm not going to train this one here, but if I take an existing one, I think there's this one here, car prediction, has been trained already. Yes. So what you can do then is you can actually say, I want to create a real-time inference pipeline. What will happen is it will actually deploy it as a service. Oops, I need to select, of course, because I have two. And so I need this one here, my boosted decision tree. I can actually say update my inference pipeline or create a new inference pipeline. What will happen is it will actually take this one. It will generate your inference pipeline in just a few seconds. There you go. So it has stripped out all of the parts which are not necessary for actually doing the inference. So the data input, the cleaning of the data prep is not in there. And so with this one, you can actually, again, submit it and then deploy it to your target environment. So deploy it as a web service to a production environment.
And then there's a separate system, meaning that you cannot do it here where you do A/B testing.
The A/B testing, no, that one does not happen here. No, so therefore, you actually need to leverage, need to get the telemetry from the model running.
Yep.
So that one, basically, we have that's part of the SDK, where you integrate or when you deploy, where you can actually specify that you want to have telemetry in there, and then afterwards, as soon as your model is running in production, you can then compare basically the telemetry from your different web services. Yeah. Of course, the A/B test. Yeah, go ahead.
So you mentioned an SDK, so I assume it's still very coding based. There's nothing on the.
You can do it two ways. So either you can get telemetry through the interface. Let me see if I can show you. Or there's two ways. You can do it through the UI, or you can do it through the code if you have a code first experience. Because of course, if you're using the designer or AutoML, you don't want to write the code, and so there as well, you can actually specify when you deploy it if you want to have the telemetry or not.
Okay. Yeah, there was an earlier question I was going to ask about. Can you choose where you run it on? I think that's the compute target on the right side. That's what it's, because if for the bigger runs, you might want to run it on, I don't know, bigger machines.
Either maybe you run it on Databricks or run it somewhere else. Yeah, definitely. Okay. So here, when you do your select compute target, this is where you will be specifying, either you run it on a compute instance or on a training cluster. Potentially, you could run it on your own virtual machines as well.
Yeah. Okay. The third question is, towards the end, you were kind of talking about how it was like this visual experience was a quick way.
Yeah.
And so it kind of indicated to me that there is a limitation compared to doing it by coding it raw in Python. So can you elaborate on what these limitations are?
Well, the limitation is mainly, or why I said do a quick test, is it's more in terms of, it's more a rapid application or rapid model development kind of experience, in the sense that you can just drag and drop and you don't need to write any code to get, in this specific case, we kind of wrote the whole thing in just a couple of minutes. In terms of further limitations, there are no hard limitations, because in terms of compute targets, the size of your data sets is all determined on the compute targets that you're running on, not on the specific visual designer. Some limitations, of course, we are limited in the number of algorithms that you have here available. So this is just a subset of the most common, in this specific case, regression, classification, clustering. There is some text analytics in there. So you have some word2vec, in-gram stuff in there, some recommendation, which is in there. There is no deep learning in here.
Okay.
So that part you don't have here out of the box.
Is it on the way?
That one I don't know.
Okay.
Probably I would not be allowed to disclose it. But yeah.
But even then, You can execute R scripts or Python scripts here.
Yeah, so you could, but then again, yeah, you need to see how much custom Python do you put in here versus mixing up with designer part. So then maybe you will be better off running it straight into a notebook if the bulk load of your logic is already in this Python Python script here. Yeah.
We have a question.
No really functional differences. Yeah, go ahead.
Yeah. Can we get the raw code from the visual experience from GitHub?
No.
No, because this is not Python. This is not R.
No.
It's a good question, though. It's a good functionality.
Yeah, we don't expose it.
So it exists. It just doesn't.
Well, yeah, of course, because this gets translated into. If you look at here in your experiments, where is it? Car price prediction is actually converted into an experiment and into a pipeline, which in turn will result in Python code being executed. So if you look at the actual outputs and logs, you will notice what is being executed. Although you don't get the actual, as far as I know, you don't get the actual Python code that is executed.
Okay.
So here you can see the actual graph of things that are being executed. If I'm not mistaken, the logs are the standard logs from Azure ML. The connection is a little bit slow here. It doesn't expose all of the details.
Okay.
I thought we did. But yeah, in the end, underneath everything, there's Python code being executed. Because if you deploy it as a web service, you will end up with basically a Docker container being deployed to a container instance or to Azure Kubernetes service. So probably you could dive into the actual image being generated to see the actual code that is generated. So there is a way. However, it's good to know that it's there, but you don't really have any control over it. The designer is really a managed experience. Okay. That answer your questions?
I think it does.
Yeah. Do we still have time for a quick AutoML demo or not?
We have 9 minutes to go.
Okay, that should be feasible. So, automated ML, automated machine learning, basically gives you kind of an even higher abstraction of, or takes you even further away from code and algorithms, in the sense that it's going to automatically check all of the algorithms that are needed for you and do so automatically for you. And so you start with creating a new automated ML run. You start from a specific data set. In this specific case, we can either say our car sales or our bike sales. Doesn't really matter. Let's say bike sales for this specific case. We can do next. And then we need to specify, maybe take some, give some data or some information about our data set. So which are the columns that we want to be taken into account? Are we doing classification? Are we doing any regression experiments? So we can say I want to use an existing one, let's say our bike demand. What is our target column? So in this specific case, target column is the count. So I want to predict our demand of bikes that are going to be rented on a particular day. Again, we can choose our training cluster. So I have two, so CPU one, or create a new one, all in here. I can say next. And then we need to specify whether we do classification, regression, or time series forecasts. In our specific case, it's really a time series forecast because we have temporal data. So we have demands from bikes. say our forecasts. Let's say our forecast is, maybe we can have some specific additional parameters. So what is our criteria for evaluating the best model? Is it using the root mean squared error? Is it R2 score? Is it the normalized mean absolute error? So let's stick to the standard one. Explain the best model. This will give us, I'll show this once it's run. It's basically going into why a specific value was chosen as we run some data through a specific model. And so here you can add some specific forecasting settings. Do we want some lagging? Do we have a rolling window size? I don't think our days. It can run for 3 hours. We want to do k-fold cross-validation over basically 5 crosses. And we run it over 3 iterations in parallel. That's because we have a 3-node cluster. And save. So we've taken our data set. We specified what type of task do we want it to do. We specified what is your metric for determining the best algorithm. And once we do finish, it will actually create a new automated machine learning run. And so it will go over all of its known algorithms for time series forecasting. Go over all of the different iterations of algorithms plus parameters, so hyperparameters, and validate whatever it needs to come up with all of the best results there. And so if we take an existing one, let's say our byte demand, so this one is run. Let's take this one. I think this one also has. So the end result is we get the best model, so our stack ensemble one, which has a root mean squared error of 0.84. Which models has it tried? So here you can actually see all of the models it has done. So it has run through, I have to see here, 77 different combinations of algorithms plus specific hyperparameters, so and featureizations. We can look at a specific model. Let's say our best model here. We have some visualizations. Let's see here, where we can actually see some predicted versus true values. Doesn't look that good. We have some bin counts, we have residual histograms, and we can also look at the explanation, which is going to tell us how it came to a specific data point, which is sometimes necessary for validating if there is no bias in your data set. So if your data is not skewed towards one or another feature. And so there you can actually see the importance of specific features within your data set. So you can see data is being calculated. Let's take this one here. Let's say I have some data in here. Why is it not showing my point? Loading. And so the explanations, which is currently still in preview, will give us insights in how it came to a specific result as part of its trained model. So if you have here, let's say we have a point in here and a predicted value of what is it? Yeah, here a predicted value of 3,630. What was basically, why is it not showing it here? Something wrong here. It's preview. It's supposed to show you why and how it actually maps to specific values of specific features to come to that specific predicted value of 3,630. It has used those specific temperature that specific instant value, that specific ambient temperature, humidity, and weather and weather situation. And so you can explain why a specific value was calculated. So this is what the explanation functionality gives you. And so this is automated ML, where you get all of the list of models, the details, some explanations if you want to. You get the you can then download or deploy that specific model as well. So if you select one, you can then again click on deploy, and it will ask you where do you want to deploy using AKS, ACI. Give it some cluster name, and there you go. And that will then deploy it as no-code deployment. So straight from the user interface, deploy your trained, that specific Stack Ensemble algorithm will be deployed to your AKS cluster and exposed as a web service endpoint. With that, we kind of gone through pretty much most of the content. So let me switch to this one here. So provide you some links. So link to the blog post, which describes a little bit in a little bit more detail the project that we ran. Some links to our documentation, some sample notebooks, again some learning data or learning information. I get all the links. If you just take a picture of this QR code, you will get the same information as the links I provided there, but just in a single link, all grouped in there. And if you're interested and want to get an Azure Learner Badger, which is just a Bitcoin-based digital kind of badger as a proof of your learning, and here you can scan this QR code as well. With that, I want to thank you and hope it was interesting. It was we had some good questions, so that was good. We made it interactive.
Yeah.
I hope it was interesting for you as well.